In this tutorial, I'm going to solve two old exam questions. The first one is from November of 2006. Sometimes IB gives you numbers in kilograms rather than grams, and many of you have difficulty with conversion. Just remember there are 1,000 grams in every kilogram. So first thing I do is convert my numbers into grams, so I know what I'm doing. So this is 2,000. In order to have grams, you have 3 more zeros added to it. Grams of CH3OH methanol, and ammonia is 2,000 kilograms, so I put 3 more zeros in front of it, grams. Now, in order to find out limiting reactant, then again you divide by their respective molar masses to convert them to moles. Methanol has 1 carbon, 4 hydrogen, 1 oxygen. So it's 12 plus 4 plus 16. It's about 32, to be exact, 0.5. So 32.05 grams per mole. In case of ammonia, molar mass of ammonia is 1 nitrogen, 14, and 3 hydrogen, 3, 17. To be exact, it's 17.04 grams per mole. These divisions, grams cancel each other out. You have moles. In case of methanol, we will have, now if you use your scientific calculators, you will have 6.24, and it's EE, which you are going to write it as times 10 to power 4 moles. In case of ammonia, you have 1.17 times 10 to power 5 moles. Another mistake I see quite often is difficult for a student to decide which one is the smaller quantity. So we divide them by their coefficient, which is 1 and 1. So I don't need to show that, but 6.24 times 10 to power 4 is smaller than 1.17 times 10 to power 5. In that case, the limiting reactant is CH3OH methanol. So the first one, what is your limiting reactant? It's CH3OH. Now, the next question, they phrased it as what is maximum mass of, rather CH3OH, sorry, this was a typo, it's CH3NH2, the product, which is methylamine. So what is maximum mass of CH3NH2? I'm going to use the limiting information, the limiting reactant. So I have 6.24 times 10 to power 4 moles of methanol. First, you have to look at your balanced equation and the ratio. And there is 1 to 1. That's a good news. So 1 mole of CH3OH in denominator to cancel it out. 1 mole of CH3NH2, your product, in the numerator. If you stop here, you will find moles of CH3NH2. Then you just simply multiply by molar mass. Let's just continue it and do it on the same setup. So molar mass of CH3NH2 happens to be, you have 1 carbon, 5 hydrogen, 1 nitrogen, is 31.07 grams of CH3NH2 per mole for every 1 mole of CH3NH2. Now moles go away. Your final answer will have grams of your product, which is the question that is challenging us. And it happens to be 1,938. I write everything that I see on the calculator. You also have 768, and it's grams. But they want it usually in kilograms, the same unit they have given it to you. So I'm going to divide it by 1,000 and report it as kilograms. Once you do that, it goes 3 decimal places back. So you have 1,939, I rounded up, kilograms of product, which is CH3 and H2. So if you have kilograms instead of grams, do not panic. Do the same treatment, except first step is convert them to grams. Let's go to the next question. In May of the same year, they have a stoichiometry question that again they gave kilograms. You have iron 3 oxide plus carbon. This usually takes place in a furnace in order to produce iron, pure iron. The first question is, what is limiting reactant? I have kilograms, so then again I multiply by 1,000, reported as grams. So I have 30,000 grams rather. 5 kilograms is 5 times 1,000, so it's 5,000 grams. Then I'm going to divide them by their molar masses and find moles. Fe2O3, you have 2 iron and 3 oxygen. Its molar mass is 159.7 grams per mole. In terms of carbon, it's 12.01 grams per mole. The first reactant, Fe2O3, I will have 188 moles. In case of carbon, I will have 416 moles. Now let's divide by their coefficients, and the smaller quantity indicates that's the limiting reactant. 188 divided by 2 is 94. 416 divided by 3 is 138. 94 is smaller, therefore Fe2O3 is my limiting reactant. Then the question follows. There is usually second part. What is maximum mass or theoretical yield of Fe, one of your product? So let's go after our moles of Fe2O3. You have 188 moles of Fe2O3 to start with. Let's use our balanced equation. For every 2 moles of Fe2O3, I produce 4 moles of iron. So 2 moles of Fe2O3 in denominator. Cancel it out. You have 4 moles of Fe. Now you have moles of Fe, multiply by its molar mass. For every 1 mole of Fe from periodic table, its atomic mass is 55.85 grams. So final answer will be 20,999.6, and this is grams of Fe. They usually want it in kilograms, so I'm going to take these decimal places or divide this by 1,000, so 3 decimal places back, and I'm going to round it up. So it's 21 kilograms of iron being produced. And that's your second question being answered. Until next tutorial.